This is another question on RTD, and it's a combination of RTD with an op-amp circuit where one of the resistance is the RTD. The problem is stated as: in the circuit below, the op-amp is ideal and the sensor is an RTD whose resistance is R theta equal to 1000 multiplied by 1 plus 0.004 times theta ohms, where theta is the temperature in degree centigrade. The output sensitivity in millivolts per degree centigrade is dash. Numerical type question, and this is the corresponding circuit for it. So we can solve this circuit by looking at the fact that this 5 volt can be divided into these two branches, and so you have 5 volt connected to 10 kilo ohms and then another 10 kilo ohms. So this bottom part forms a voltage divider, and then over at the top part you have the resistance of the RTD R theta, which is a function of temperature, connected in the feedback loop. Now if we look at the non-inverting portion, because this is a voltage divider, so the voltage at this node, which we can term as V plus, should be equal to 10 kilo ohms divided by 10 kilo ohms plus 10 kilo ohms multiplied by 5 volt, and this is half of 5 volt. So voltage at this node is equal to 2.5 volt. And then using the concept of virtual short, we know that voltage at the positive terminal should be equal to the voltage at the negative input terminal of the op amp, and therefore voltage at this node is also 2.5 volt. Note that the op amp is an ideal one. And then if we look at the top branch, so you have some current, let's call it I1. I1 is flowing from this 5 volt source, and then if we call this current as I2, then I1 must equate to I2 because the input terminal of the op amp draws no current. This is true for an ideal op amp. So writing I1 is equal to I2, we can frame the expression as 5 minus of 2.5 divided by 1 kilo ohm, and this must equate to 2.5 minus of V0 divided by R theta. And if we proceed with the algebra, it's not difficult to show that V0 by theta, which is the output sensitivity, equates to negative of 0.01 volts per degree centigrade. Note that output sensitivity means the output variable, the output parameter of interest here, which is V0, and the input parameter is given by theta or temperature. And because the answer is required in terms of millivolt per degree centigrade, you can go one step forward and write this expression as minus of 10 millivolt per degree centigrade. The sensitivity is usually calculated in absolute terms, and therefore if I take mod of V0 by theta, the sensitivity value becomes 10 millivolt per degree centigrade.